All right, guys, welcome. This is going to be the Unit P review key. All right. Um, so I just want to kind of say, since this is our first one, I'm not going to be teaching the stuff to you on this. If you want to know like how to do these things, all right, there's videos going in depth on all of these topics. All right. What I'm going to be doing today is just simply solving the problems and telling you, what you need to be doing and explaining the thought process behind each step. So it's going to be quite long. I assume this review is 3 pages long. So you don't need to watch this whole thing. All right. Just skip around to the questions where you were having trouble on if you want to hear an explanation rather than just look at the key. So we're going to go ahead and get started. The first topic we have, all right, is solving equations. So when you're solving equations, hopefully you can do these ones right here, these first couple ones, but you're simply trying to get x by itself. If you have a fraction, all right, in front of the x, remember, multiply by the reciprocal. So we're going to multiply by 2 here to cancel that out. So we get x equals negative 12, and that is our answer. Number 2, all right, we have an x on both sides. When there's an x on both sides, I like to cancel out the smallest x, which in this case would be the negative number rather than the positive. That way we will have a positive x over here, 12x. So we've got 12x plus 6 equals negative 4. Now we can start solving. Subtract by 6. 12x equals negative 10. All right, so it looks like this is going to be a fraction. Oh no. That's fine. But we're going to ask that you simplify your fractions, right? So x equals negative 10 over 12, right? Those are both even numbers. So if we divide both of those numbers by 2, we end up getting x equals negative 5 over 6. Number 3, all right, we have a parentheses, all right? So here we need to distribute. And I want to remind you guys about distributing with a negative, okay? This is negative 15, and then a negative times a negative is a positive, so this actually becomes plus 3x, all right? We made some mistakes on the quiz there. Now combine like terms, since our x's are on the same side, we just add them. 7x plus 3x is 10x. Again, we can start solving, add 15 on both sides. 10x equals 25, divide by 10. All right, we have another fraction we need to simplify here. Does it say to do that? No, but it will on the test, I'm pretty sure. So 25, so both of these numbers we can say are divisible by 5, right? So 25 divided by 5 is 5, 10 divided by 5 is 2, so we've got x equals 5 halves. Number 4, right? We just have more distributive property, right? This time on both sides. So again, 5 times 4 is 20. 5 times x is 5x. Make sure you distribute to both numbers in the parentheses. We have 3 times 3, that's 9x. 3 times negative 1 is negative 3. 3 times negative 9 is negative 27. We got some combining like terms right here that we need to do. So this will stay the same. And then negative 3 minus 27, that's minus 30. Now we want to get our x's on the same side, so I'm going to subtract the smaller x, which is 5x. 20 equals 4x minus 30. We're going to add 30 to both sides. So that's 50 equals 4x. Man, we have a lot of fractions here. Divide by 4, so x equals 50 over 4. Which, if we divide both of those by 2, since they're even, simplifies to 25 over 2. Number 5. Again, so we have y's on both sides. We need to subtract the smaller y, which is 6, compared to 8. So we have negative 5 equals 2y minus 7. Add 7 on both sides. Negative 5 plus 7 is 2. So we got 2 equals 2y. Divide by 2. Y equals 1. Number 6, all right, our big fraction one. Okay, so what do we do here? All right, well, remember, we want to get a common denominator for all of our fractions, right? And that's going to be 6 here. 2 goes into 6, 3 goes into 6, and 6 goes into 6. So in order to get 6 here, this is going to be multiplied by 3 over 3. This is going to be multiplied by 2 over 2. That's just going to stay over 6. This is going to get multiplied by 6 over 6. So when you multiply fractions, you just multiply straight across. So 3 times 1 is 3. You got 3 6. X. 2 times 2 is 4. So we've got 4 6 equals 5 6x. And then 6 times -3 is -18 over 6. All right. So now that we've got all of our fractions over 6, all right, we can cancel out all of our fractions. All right. That's going to leave us with just whole numbers. So we've got 3x plus 4 equals 5x minus 18. And now this is a problem that we can solve, right, with our regular solving skills. So we're going to subtract 3x to get our x's on the same side. We've got 4 equals 2x minus 18. I'm going to shrink this since we got down to the bottom here. Plus 18 gives us 22 equals 2x. Divide by 2. 22 divided by 2 is 11. All right, so there's solving equations. Next, we're going to talk about some rewriting formulas, all right, solving literal equations. So when you're solving literal equations, remember, whatever letter you have, you want to get by itself. So that's G here, solve for G. The numbers in front, right? If you have a fraction in front, we want to get rid of that by multiplying by the reciprocal. So we're going to multiply by 2 on both sides to start in order to cancel that out. So we've got 2s equals g times t squared. Now you might be a little bit confused about this t squared, but remember, we're only trying to get g by itself. So since this is a multiplication problem right there, all we're going to do is divide both sides by t squared. Okay, so those will both cancel out. And we've got our final answer of g equals 2s over t squared. On this one, all right, we're going to solve for y right here. So you should be able to do this. This is solving for an equation in standard form, right? Remember, this is 2 steps. We're going to subtract 5x on both sides. That cancels that out. Now we've got -6y equals, it doesn't matter, 6 minus 5x. Now we want to get the y by itself, so we're going to divide both sides by -6. That gives us y equals. Now, you could just leave it like that, all right? That's fine. You could also get rid of that negative on the bottom, but, you know, it's really not that big of a deal, to be honest. So y is by itself. Now we're done. So that's literal equations. Now we're going to do a couple on inequalities. So that's what we did just this week or last week, depending on when you're watching this video. So again, we're trying to solve for x. So we're going to subtract 3 on both sides to get rid of that. So now we've got -2x is less than 14. Now we need to divide by -2. And since we're dividing by a negative, we have to do our flip rule, which is going to flip this to positive. So x is greater than positive 7. So we're going to put, no, not positive 7. X is greater than -7. So we're going to put -7 on our graph. Since there's no line underneath our symbol, we're going to put an open dot. And since it's greater than -7, we're going to go to the right. In interval notation now, we're starting at -7, and it's an open dot, so we're going to use parentheses. And then on the right side, we see our arrow, which means it's going to infinity. We're done. Number 8, all right, we're going to do the same thing, solving for x. So we're going to start by subtracting 5 on both sides. That gives us 2x is less than or equal to 18. All right, divide by 2. X is less than or equal to 9. So now we're going to go to our number line. We're going to put 9 somewhere on our number line. This time, since there is a line underneath, we're going to put a positive, or sorry, why do I keep saying the word positive when it doesn't apply? We're going to put a closed dot, And then since it's less than 9, all right, the numbers less than 9 are to the left. So we're going to draw our arrow to the left. Now doing our interval notation, right, on the left side, we have a parentheses. So going to the left, that's going to negative infinity. On the right side, we're at 9. So we're going to end at 9. And since it's a closed dot, we're going to use a bracket. Number 11, we have a compound inequality, all right? So we need to solve for x. So we are going to add 2 on both sides. Or not both sides, all 3 sides really. That's negative 5 is less than 5x, which is less than or equal to 10. Now we're going to divide by 5. All right, this becomes negative 1. This cancels out as less than x, which is less than or equal to 2. All right, so now we're going to have 2 dots here. One at negative 1, one at 2. So when we fill this in, we want to make sure we get all those numbers. So right here, we have no line underneath. That's an open dot at negative 1. That means we have a closed dot at 2. And since x is in between those 2 numbers, we're just going to draw our line in between those 2 dots. So our interval notation, right, on the left side, we have a negative 1 with an open dot. On the right side, we have a 2 with a closed dot. So we're going to do in that with a bracket, and that is our interval notation. Number 12, we have OR, all right? OR means we have 2 separate inequalities that we need to solve on their own. So we've got 4x is less than negative 2, divide by 4. So interesting here, we're actually going to get x is less than negative a half, all right? Over here, we add 3 to both sides. 2x is greater than 14, divide by 2, x is greater than 7. So since we're putting a number at a half, right, we want to make sure we get all our numbers on both sides of that. So we're going to go 0, negative 1, 1. Now we need to get up to 7. So 2, 3, 4, 5, 6, 7. You don't need to go past that. You can if you want. So our first dot is at negative a half, and that's an open dot. Now, since we're less than that, we're going to be going to the left. We're also going to have another open dot at 7, and since it's greater than 7, we're going to have our arrow going to the right. So this works, all right? Or means they should be going opposite ways. So now we're going to have 2 interval notations, one for each. So if we look at our first one, we start at negative infinity. We end at, as we know, negative a half. Then we have a big gap, so we're going to skip. All right, our second interval starts at 7. And then on the right side, we have an arrow, so it's going to go off to infinity. So those are the answers to the graphing and solving linear inequalities. Next, all right, slope and rate of change. So it says find the slope of the line that passes through the points. So for all of these questions, all right, we're going to be doing the same formula. I'm only going to write it one time here. All right, it's y2 minus y1 over x2 minus x1. Remember, we label points x, comma, y, x, comma, y. So we want our y values to be on top, so that's 2 and 0. So we've got 2 minus 0 on top. On the bottom, we have 4 and 2. So 2 minus 0 is 2. 4 minus 2 is 2. 2 over 2 is 1. So it looks like our slope is 1. Next problem, all right, x, y, x, y. This time our y values are negative 4 and negative 3. So we've got negative 4 minus negative 3. Remember, we were subtracting in negative, right? So we need to have 2 signs there. Then we have negative 6 minus 3. So the 2 signs, right, 2 negatives make a positive, so this becomes plus. So negative 4 plus 3, that's negative 1. Negative 6 minus 3, that's negative 9. All right, and when we have 2 negatives here, all right, they cancel out, and our answer will become positive 1/9. Number 15, same thing, all right? Our y values are 2 and 2, so we've got 2 minus 2. Then our x values, we've got 5 minus 0. So interesting here, 2 minus 2 is 0, all right? 5 minus 0 is 5, so this slope is actually just 0, all right? If 0 is on the top, that means your slope is 0. Number 16, all right, our y values are -4 and 0. So we've got -4 minus 0. Our x values are both -4, so we've got -4 minus -4. These become plus signs for the same reason they did on the other example. -4 minus 0 is -4, and then -4 plus 4, right, that actually is 0. So this slope is actually undefined, all right? If you have a 0 on the bottom, that's not a number, all right? It's an error. You can't divide by 0, so we have undefined. Next, graphing, all right? We're going to do some graphing ones. So the first one, this is in slope-intercept form, all right? So our slope, it gives us to us, that's our m value right in front of x. Our slope is 3/4. Our point is our y-intercept, all right? If you remember how to write the y-intercept, it's always 0, comma, whatever the y-intercept is. So in this case, -5. So we always start at our point. So we're going to start with a dot at -5. And then we're going to count off our slope. Our slope is 3/4. So that's rise over run. So we're going to go up 3/4. And again, you can put as many points as you feel is necessary. And then once you've got enough points, you can connect your line. That was a bad line. And we're done. Next problem, this is in point slope form. So in point slope form, remember this number out in front of the parentheses is your slope. That's -2. Our point comes from this value and this value, except remember they're the opposite signs. So this is actually going to be -4, and that's going to be +2. So that's our starting point. So we want to put a point at -4 and +2. Now we want to count off our slope. Our slope is -2/1, all right? So negative means we're going down, all right? We're going down 2, and we still go to the right, all right? So down 2/1, down 2/1, so on and so forth, until we feel like we've got enough points where we can make our line. So if your slope's negative and your line isn't going down like this is, all right, then you have your graph wrong. Last one, standard form, all right? In order to graph this in standard form, remember, we have to turn it into slope-intercept form, all right? So we're going to start by subtracting 3x on both sides, because if you want to turn it into slope-intercept form, all right, that means we want to get our y by itself. So we're going to move our x over. Then we're going to divide by 2 to finish getting y by itself. When we divide by 2, we divide by both our terms on our right side by 2. So this first term, we're just going to leave that as a fraction, all right? That way we can see the rise over run. Our second one, 2/2, that's 1, all right? So now we know our slope is -3/2, and our point is our y-intercept right there, which is 0, 1. So we're going to start at our y-intercept, all right, which is 1. And then our slope is -3/2. So we're going to be going down 3 and to the right by 2. Again, since our slope is negative, our line needs to be going down, all right? If your line is going up, you have your graph wrong, all right? The negative only affects the rise, not the run. So these are your 3 answers for those problems. Next, we are going to write equations of lines, all right? So we're going to do these, and they're actually going to tell you a form, all right, that you should use. It's important that your answer is in the form given. So this first question, we want this to be in point slope form, okay? So point slope form, that's y minus y1 equals mx minus x1. Don't forget those parentheses, all right? You guys did that on the quiz. So our m, it even tells us right here straight up, our m is negative 2 over 3. Our point comes from these numbers, right, x and y. So our x point, that's negative 3. So when we plug it in, it ends up being the opposite. So it ends up being plus 3. Our y value is 2, so that's going to be minus 2. So this is our answer. That's it. All right, you plugged it in, you're done. All right, that's in point slope form. Number 21. All right, we're also going to do point slope form. So this is pretty much the same thing that we just did. All right. So again, they give us a slope of negative 3. We're going to plug in our point. Our x value is a half, so we're going to have minus a half here. Our y value is 2, so we're going to have y minus 2. All right, and that is it. We are done. Number 22. Okay, so this one they actually want in slope-intercept form. So when we put things in slope-intercept form, all right, when they're giving us a point that's not our y-intercept, we're first going to put it in point slope form. All right, so when we put this in point slope form, our y value over here is negative 2. So we're going to have y plus 2. Our slope is 0. And then we have our parentheses x minus 7. All right, so the reason it's important to have the parentheses is because we need to distribute here, all right? It's interesting because here 0 times 7 is 0. 0 times negative 7 is also 0. So really, this whole thing goes away. So we just have y plus 2 equals 0. Then we're going to subtract 2 on both sides, which means y equals negative 2. And that makes sense, right? That we have just a letter by itself because our slope is 0. And we know that's what happens. Number 23. Here we have 2 points, all right? So we need to use our slope formula from above, all right? Our y2 minus y1 and x2 minus x1. All right, so our two y values here are 2 and negative 19. Wow. So that's going to be 2 minus negative 19. Then we're going to have negative 2 minus negative 1. So for both of these, all right, these are going to end up being plus. All right. So 2 plus 19, that's 21. Negative 2 plus 1, that's negative 1. So 21 divided by negative 1 is negative 21. So our slope, all right, is negative 21. Now, they want this in point slope form, so I'm going to go ahead and start that. Our slope in point slope form comes right after our equal sign. And now we're going to plug in either of these points. So it really does not matter. I'm actually going to plug in the first point, so I'm going to plug in my y value of plus 19 because it's the opposite. That's negative 19, and then x plus 1 because that's negative 1. And this is our answer. Next problem, all right, parallel. What does parallel mean? All right, parallel means the slope is the same. All right, so we want this in slope-intercept form, so we're going to have y equals 2x because we want the slope to be the same. And they actually tell us here what they want the y-intercept to be. So they want the y-intercept to be at 3. Right, that's what that means. If x is 0, that's your y-intercept, all right? So we've got y equals 2x plus 3. And we're done because that's in slope-intercept form. Next problem, all right? This time they're giving us not our y-intercept, but luckily they want it in point slope form. And they actually want it to be perpendicular, all right, to this equation. Now, perpendicular means two things, all right? Perpendicular means your slope is going to be flipped upside down, all right? So our slope is going to be 1 over 2 instead of 2 over 1. It also means it has to be the opposite sign, all right? So we're going to have negative a half since that is positive 2. Now we're going to plug in the point they gave us. So our y value is 3 in that point. So we're going to have y minus 3. Our x value is 2. So we're going to have x minus 2. And we are done. All right. That is our equation for point slope form. Last two questions, right? We're almost done. Next, we have some word problems here, all right? This says Seth's father is thinking of buying his son a 6 months movie pass for $40. With the pass, matinees cost $1. Write an equation to model the total cost. C that he would spend on the pass if Seth sees X number of movies. So we're modeling how much he's paying for the plan, all right, the total cost. So since the total cost is C, we're going to have C equals. Now, we have two things going on here, all right? The first thing is that the movie pass costs $40. The second thing is each matinee, that means each movie he goes to see, all right, is going to be $1. So you have to think here, all right, what are we being given? All right, we're being given a one-time fee, all right, of $40, and then something else, $1 that happens over and over again. So if you ever have a one-time fee, all right, that means your equation is going to be in slope-intercept form, all right, because that one-time fee, that's your starting point, all right? So even if he's seen no movies, he still pays that $40, right? He pays that up front. Then we have our slope. Our slope is whatever is happening over and over again. All right. So the slope here is $1 because each movie is $1. So we're just going to have 1x plus 40. So it says matinees are normally $3.50 each. These are the cheapest movies of all time. What movie theater is movies that cost $3.50? I don't know. Anyway, so it says if Seth sees 15 movies, is it worth it for his father to buy the pass? So let's figure out, all right, if he sees 15 movies, how much would that cost? So remember, X represents the number of movies, all right? So we're going to plug 15 in for X. That'll give us the cost. We have C equals 1 times 15 plus 40. Well, 1 times 15, that's just 15. So we have 15 plus 40, which is 55, all right? So that will cost him $55. Now, if he didn't have the pass, all right, and he was paying $3.50 per movie, that would just be $3.50 times 15. Let's figure out what that is. So I'm going to get my calculator for a second to make sure I don't mess this up. So 3.5 times 15, that's 52.5. So if Seth saw only 15 movies, all right, would it be worth it? No, right? He'd be paying $55 when normally he'd be paying $52.50. So it's actually would be more expensive with the pass. So you'd have to see more than 15 movies in 6 months for the pass to be worth it. That doesn't sound like a good deal to me. I don't know who goes to see that many movies. Maybe you do, but I definitely do not. Last question, all right? You are running a concession stand at the basketball game. You sell hot dogs for $1 and sodas for 50 cents. At the end of the night, you made $200. Let X represent the number of hot dogs sold and Y represent the number of sodas sold. Write an equation to model the situation. So this is not going to be slope-intercept form, right? We have no one-time fee here. We actually have two things that are happening over and over again. $1 for hot dogs and 50 cents for sodas. And we know the total is 200, all right? So we're going to have 200 equals, all right? So a combination, so we're selling hot dogs and sodas. So X is going to represent the number of hot dogs. So each hot dog is selling for $1, so we're going to have 1 times X. And Y is going to represent the number of sodas sold. So that's 50 cents per soda, so we're going to have 0.5 Y, all right? Every time we sell a hot dog, we make $1. Every time we sell a soda, we make 50 cents. So this question now says for part B, you had 150 hot dogs to start the night and only had 8 when you were finished. How many hot dogs did you sell and how many sodas did you sell? So if we started with 150 hot dogs, all right, and we finished with only 8, that means we sold 142 hot dogs. So there's already one of our answers. Next, we're going to use that to figure out our sodas, right? We're going to go back up to our equation and we're going to plug in 142 for x, because x is the number of hot dogs. So we have 200 equals 1 times 142 plus 0.5 times y. Why did I put that in parentheses? I don't know. So 1 times 142, that's just 142. So I'm just going to subtract 142 out because that's how much money we made off the hot dogs. So what does that equal? That equals 58, all right? So 58 equals 0.5y. We're going to finish this off by dividing by 0.5. 58 divided by 0.5, that should be 116. I just did that in my head. I hope I'm correct. 116. So we have 116 sodas sold. All right. And that's it. So that is the key. All right. If you can do everything on this key, you can ace the test. All right. So make sure you look this over. Make sure you know how to do all these different topics. All right. Take your time. Check your work. Good luck on the test. If you have any questions, let me know. Thanks and have a